All right, all right. Thank you for joining up. So this is going to be the 6 weeks redo. Instead of giving you the test all over again, we're going to do this together. You should have a worksheet with all these problems. Please copy everything I write down on this document. If you turn this in, or if you take a picture and send it to me, you will be able to get half your points back. So this is going to be the redo again. So please make sure you're taking everything in terms of notes. Anything that I write down, you must write down on your paper, please. So looking at the first problem, they are not in order. I just copied and pasted some of these problems over here. So problem number one says a student ran a cross country race from school to a local park. The graph shows the student's distance in miles from the park after running X minutes. Again, we have a nice little graph here, right? So again, the most important thing that we have to do is recognize what are we talking about. So here we have distance from the park and I have time in minutes, right? So looking at the graph here, we're going by fours. Over here, we're cutting by ones. And then that's the title, obviously, right? Now, again, looking at this graph, well, we know that we have a line that is decreasing. And again, showing us the relationship between distance and time. So next, the question here says, what is the domain? All right. Now, again, if you were on your test, you should have circled this word as being important. This is domain, right? So on your paper, make sure you highlight the word or underline it or whatever. Again, I'm doing something new here. I apologize. I'm a little new to this setup here. But what is the domain of the function? So let's not forget, what is domain? So again, please write down everything that you're supposed to on this piece of paper, please. Domain. Well, oh, my apologies. Domain. What? Give me a second. My apologies. Domain, if you guys recall, is the set of inputs. All right, maybe I have to do this. My apologies. All right. Domain is a set of inputs, right? So domain is the set of inputs. All right. That is what domain is. So on the left side of the graph here, go and write that down, please. Domain, it is the set of inputs. One second here. Still trying to get this formulated. All right. So what does that mean, right? Well, if we're talking about the set of inputs, well, first of all, we have to recognize what is the domain. Well, domain, if you guys remember, is X. It's the set of inputs. So when we look at the graph here, what are we discussing? Well, yeah, we have two different categories. We have distance and we have time. But again, domain is a set of X's. So when we go to look at our situation here, well, what X's are we talking about? Well, you can sit here and give yourself like a little ruler here, right? If we're looking at 4, does X4 have a point? Yeah, it's right here. What about 12? Yeah. What about 20? Yeah. Well, what's the highest X that we use? Well, the highest X is 40. All right. What's the smallest X? Well, if you look at this problem here, the smallest X is actually this point, which when we scroll down is what? 0. So what is your domain? Well, your domain is everything that is used. It is a set of inputs. So my inputs are everything on this line. Again, I apologize. I'm using this, the weird mouse. So anyways, there it is. So what was my domain? Well, my domain starts at the smallest number, which is 0, and it goes up to the biggest number, which happens to be 40. Again, here, just to show you guys, there's a 40. So your domain is 0 to 40. There's two ways to write this. We can write this 0 is less than or equal to x, which is less than or equal to 40. Or, I believe how they had it on the test was, give me a second. was x is greater or anything greater than or equal to 0 and less than or equal to 40. Oh man, I thought this would be. Can I make this smaller? Probably not. It's okay. So again, write that down on your notebook, or I'm sorry, on this piece of paper. This should be a little bit more to the left here. I'm going to put it right here or at the bottom if you'd like. There it is. So that is the domain. The domain is anything that is greater than or equal to 0 and less than or equal to 40. Because again, if we look at the graph, there it is. All these x values, which are my inputs that are used. It is the set of inputs. So when we look at this graph, any x value is used between 0 and 40. 0, 1, 2, 3, 4, 5, 6, 7, anything up to 40. Notice how once it goes past 40, I don't have a graph anymore. So again, make sure you have this on your piece of paper. That is problem number 1. All right. Now let's go to problem number 2. Problem number 2 says, the graph below shows shows a line segment on a coordinate plane. So now we have a line segment, right? So again, what is the domain and range? First thing we need to do is, again, identify what is important. So I'm looking for domain and range. So on your piece of paper, make sure that you are highlighting these words. Now again, we're going to write what it means to be domain and range. So domain and range, domain, which equals x, is a set of inputs. Range, which equals y, is a set of outputs. Now remember, a lot of you guys, I don't know if you guys are getting some of these confused, but input and output is the coordinate points that we're talking about, right? But remember, x goes in, output comes out. So when we're looking at this line, we can't forget, we have a whole bunch of points that made up this line. When I was reading some of your guys' OER responses, again, some of the definitions were a little confused. You guys were saying like there's only one range for every x, or you guys were getting function confused with some of these things. No. So remember, every single point in here is an input and an output. It's a coordinate point. Domain is a set of x's. Y is a set of, or is a range, right? So looking at this, there's actually a really simple way. All you got to do is take your endpoints. So again, let's break it down here, right? It's a set of x's. So when I look at the x's here, right? I'm using orange or red for x's. If you look at this, do we have a point when x is negative 8? No. Notice how there's no point when x is negative 8. What about negative 7? No. Notice how it starts at negative 6. So what you do is you project this point down. And I'm going to put a circle around it. Why? Because remember, it's an open dot. We know that this is open. It's not equal to, right? It's either greater than or less than. So look, I took this point and I projected it down. If you look at all the x's from here, if you go to negative 4, does it have a y? Yeah. What about negative 3? Yeah. What about negative 2? Yeah. Notice how it keeps on going. But what about on this side? Do we have a point when x is 8? No. Notice actually stopped right here. So this point, I projected onto the x, and I'm going to make my circle here. So notice how all these points exist when x is between these 2 points. So what is our domain? Well, my domain is anything between negative 6, anything greater than negative 6, and less than or equal to 3. All right. I'm going to draw this the way I think they had it on the test. So my domain, let me type it out here for you. So domain and we also had range. Give me 1 second. My domain. Well, my domain, as you can see, is anything from -6 to 3. So I believe you can actually write it like this, or in your test, they probably have something like this: -6. Again, I apologize. I'm doing a little something new here. Is less than. Notice how x is in between -6 and 3, and it's an open dot. So it is not equal to. X is my domain, so I have to put an x because this is a set of x's. Now x is less than or equal to, because it's a solid dot, and it is 3. So that is my domain. My domain is any x between -6 and 3, which is what this says. X has to be greater than -6, and x has to be less than or equal to 3. Well, what about your range? Well, look, range is what? The set of outputs. But if you remember, we can look at all the points. So here, what is the highest point? What's this one? What does this project to on the y? Well, this is at a value of 9. What about the lowest point? Here, it's at a -8. But remember, why am I looking at these two? Well, we understand that these are all points, input and outputs. So when x was some number, we got a respecting y, right? So in this case, notice how when you go to y is 10, do we have a point when y is 10? No. The biggest that it goes is to 9. And notice how if you go to 8, does it have a point? Yeah, it's right here. What about 7? Yes. What about 6? Yes. What about 4? Yeah. So notice how here is anything from 9 to -8. So in this case, my range, starting from the bottom, is a -8. Now again, notice how it is a solid dot, right? Look at your dot here. It is solid. So y has to be greater than or equal to. Why? Because we're shading the top portion of it. Y, indicating my range. Now look over here. This was 9. And what was happening with the y? Y is less than. Notice how this line is going below the 9. So it has to be less than 9. And notice how it's an open dot. It is an open dot, therefore this is less than. All right, all right. Let's go. Oh my goodness. Let's undo that. All right, let's go to the next problem here. Oh, sorry about that. This problem here. Again, I'm not going in any specific order. I apologize. I kind of just pasted them onto this document here.